Assalamu alaikum. I am Sumbul Zehra, lecturer in physics at Sir SyedGovernment Girls College. With the support and guidance of our very honorable and worthy Principal Professor Khalida Parveen, today I am delivering my 15th lecture of the BCS Physics first semester course, which is on the topic of magnetic field due to straight current carrying conductor. Let's start with our topic, which is magnetic field due to current carrying conductor. We have already discussed in our previous lectures what is Biot-Savart's law. With the help of Biot-Savart's law, now we are doing very important derivation, that is magnetic field due to straight current carrying conductor. AE is a straight current carrying conductor as shown in the diagram. P is a point at normal distance r. We have to find magnetic field at P due to current I. At all points, magnetic field is different. So we have to specify where is our P. So question arises, how do we specify P? We can specify P. We can specify that from point P, we see the elevation of one end, that is point A. How much is theta 1? Other end, how much is the elevation, that is minus theta 2. Negative sign is because theta 2 is in the opposite direction. If E changes its position, then theta 2 is changed. If A changes its position, then theta 1 will change. In this way, P has a very peculiar and exact position which is specified by theta 1 and theta 2. At this place, we have to find the magnetic field. Now, we take any one small portion of the current carrying conductor, which is ideal conductor as we suppose, and we will find the magnetic field of this small portion. Then we will integrate it from portion A to C to get total complete magnetic field of this whole current carrying conductor. At any one position, that is CD, we have supposed position we take the DL. DL is so small that this DL has elevation from point P equal to theta. The value of theta for A is theta 1, for B is theta 2. Theta, which is general value for any DL, that keeps on changing from theta 1 to minus theta 2. So at any general angle theta, we have taken a small element DL. The current flowing is I, and because of this, we will find out a small magnetic field dB. And for this, we will take the help of Biot-Savart's law. Magnetic field due to element I, dl, using Biot-Savart's law is dB equals to mu naught upon 4 pi I dl sin phi over r square. This is what we have studied before, is Biot-Savart's law. R is our distance from dl to the point P. The known quantities for us are angle theta and capital R and current I. So now phi is the angle between C and F. So how much is CF? CF is equal to CF upon DL equals to sin phi. So CF equals to DL sin of phi, or dl equals to CF upon sin phi. This is the value of dl which we replace in the above equation of Biot-Savart's law. So by putting value of dl, dB equals to mu naught upon 4 pi I CF अपॉन साइन फाई इंटू साइन ऑफ फाई। तो साइन फाई से साइन फाई आपका कैंसिल हो जाएगा। डी बी इक्वल्स टू म्यू नॉट अपॉन 4 पाई आई सी एफ अपॉन आर स्क्वायर। Consider triangle CFP in which d theta is the very small angle. Then for very small angle, how do we measure angle in terms of radian? Is the arc per radius is known as radian or arc upon radius. How much is arc? So arc is CF and r small r is the radius. So once again CF upon small r equals to d theta. So CF equals to r d theta. Now putting value of CF in equation, तो dB equals to mu naught upon 4 pi I r d theta upon r square. सो r से r स्क्वायर जो कैंसिल हो रहा है, तो डी बी इक्वल्स टू म्यू नॉट अपॉन 4 पाई आई ओवर r इंटू डी थीटा. सो हाउ स्मॉल r इज रिलेटेड टू कैपिटल R. सो इसके रिलेशन के लिए अगेन कंसिडर ट्राइंगल BPC. So cos theta equals to r is capital R over small r, because cos theta equals to base upon hypotenuse. So 1 over r small r equals to cos theta upon capital R. This is the value of 1 over small r. So putting the value of 1 over r in the above equation. So dB equals to mu naught upon 4 pi I d theta cos theta upon capital R. Now you can see I had deleted dl, there is no more, so I had changed dl into r phi and all are converted to theta capital R, because r phi and dl are not given quantities and theta capital R are given quantities. So we have replaced all the ungiven quantities into given quantities. So now this is the formula for the magnetic field due to current I at normal distance r, where point P has elevations theta 1 and theta 2. So all known quantities r, theta and I is in the formula. Theta has limits from theta 1 to theta 2. If these values changes, then values of magnetic field also change. So this is a very versatile derivation. Sometimes it cannot be asked directly, but it has got many applications. So there are applications where point P has locations at different points, and because of that values of magnetic field changes. If conductor we are taking is limited, and if the length of the conductor is unlimited, then other solutions. If it is limited, then this is the only solution. So that's all for today. Thank you so much.